Special moves. They are the lifeblood of RPG combat. They are what turn a simple exchange between adversaries into a duel of wizardry, arts, and swordplay. You see them in all types of games. Pokemon gives you 4 of them, Mario just makes them up, and Final Fantasy VII gives you as many as you can cram into your sword. But in the end, they all work the same. You press the skill, you select the enemy, and things happen. But wait, what's actually happening? What's happening in the land of zeros and ones? How does the skill system know exactly what to do with only 2 pieces of information? And how can developers make so many different abilities? To be honest, no sane human asked these questions, but I'm a developer, my brain's already not normal. So today we're going to dive into Project Bloom's skill creation and management systems to better understand what happens behind the scenes of some of your favorite games. So Project Bloom runs on an active time battle system, meaning things happen in real time. You press a skill and the effect happens immediately on screen. Early in development, and I mean really early, skills were handled by hard-coding the effect directly into the unit's script. For example, a method called Fire Skill would cast a fire spell, while a method called Sword Slash would cast a slash attack. Pretty basic, and this could honestly work for any small-scale project. The problem with this method is I'd have to hard-code each and every skill, and that's not practical. Project Bloom had to be built for scale, therefore I needed a modular system. I needed a way to build as many skills as possible and simply tell the unit, hey, just use this skill right here. And some bonus points if I could just drag and drop it onto the unit's game object. Well, fortunately, Unity has a pretty convenient solution. Introducing scriptable objects. To keep it brief, a scriptable object is basically a file that contains information. You can put all of the information you want inside of it and save it as a file inside of your project folders. As a quick example, let's say you want to make a weapon for your game. Well, you can make a scriptable object called weapons, define the parameters that make up a weapon such as its name, artwork, and stats, and then save it in your project files as different and unique weapons. This is the first step to creating our skill system. We define a scriptable object called skills and list all of the things that we need to know about that skill, such as its name, some stats, and a particle effect, and then save it as a file in our project. Normal people would probably have 5 to 10 pieces of information they're tracking. My dumbass has about 50. On top of the previously mentioned parameters, I'm also tracking some other simple information like the number of hits and the ability cost. But I also track some highly specific ones like does the skill trigger camera effects? Or does the skill have screen shake? Is it an AoE? If so, where is the AoE positioned? Does the skill have an effect? Does the effect happen before or after battle calculations? What character animation does it trigger? There are many more tuning parameters I need inside of a skill in order to ensure that it behaves how I want it. I imagine games with massive skill libraries handle it in a similar way. Once we stuff the skill with information and save it as a file, we can drag and drop it onto the unit. From there, it's just a matter of accessing that information. So we solved the first half of the equation, which was creating a modular system for pumping out skills. But how is that information interpreted? Well, in Project Bloom, I decided to dump all of that headache onto the Battle Manager. The Battle Manager tracks all of the details pertaining to combat, what units are fighting, what skill is being used, damage calculations, and many more micro details. Each time a skill is selected, the information is queued up in a list and provided to the Battle Manager. From there, the manager runs a function called doAttackQueue. This is a very bloated function that goes through that list of skills and reads all of the details and handles it accordingly. This includes position of particle effects, handling skill effects, triggering guard prompts, and doing battle calculations. It also does more specific tasks like correcting the player's target in the event that the enemy dies just as you were attacking. I'm really oversimplifying it in this example, but there are really over 1,000 lines of code that run each time someone attacks. But let's give a shout out to modern PCs for carrying my unoptimized spaghetti code. So we can create some skills, assign it to units, and have the Battle Manager interpret the information. But over time, I've learned to use the system in ways I didn't originally intend. Nearly every action in the game is technically a skill. Regardless of what it ultimately does, if it interacts with the battle system, it's probably a skill. For example, the Gunner's Steady Aim effect is actually 2 skills. The first being a skill whose only effect is to start the charge sequence and slow down the game time, while the second skill is the actual attack that triggers when the button is released. But this system extends past traditional skills. Let's say I have an item that causes an AoE explosion whenever you're attacked. Well, that explosion is just a skill. Whenever you're hit, it just triggers a skill. Or if a unit has a passive that reloads bullets, that too is just a skill. I could have made a separate system for each of these use cases, but keeping it all tied to the skill system allowed me to utilize the already built code for placing particles and sound effects. When it's time to hyper polish the game, I can just go in and drop all the particle and sound effects into the skills and the system already knows what to do with it. I don't need to build a new system. So now the system is built to handle the majority of skills I'd like to make. However, if the only information used were the ones immediately found inside of the skills, then things wouldn't be all that interesting. What really pushes the system to the next level is the ability to assign skill effects. From a developer point of view, effects are just another set of scriptable objects. I can create effects and save them as project files, then drag and drop as many effects onto any skill. However, the difference between creating effects and creating skills is that skills have a lot of common information that gets interpreted by the battle manager, being that they all have a name, they all have a damage, they all have a cost, etc. Effects, on the other hand, have very specific things that need to be coded, like raising stats or applying status effects. So unfortunately, I do have to make a lot of skill effect child scripts that use the base script as its parent, but it's all for the greater good. The end result is a system that allows me to slot any number of effects onto any skill. If I want to create a fire explosion that buffs allies, burns the target, makes them jump, and slows down time, I can do that just by slotting each of those effects into the skill. Pretty cool. Now that's not to say that this system is flawless. There are a lot of nuances I wish I could improve on without completely breaking my game. Specifically, I don't like that I have to do a lot of manual inputs for things. This opens the game up to numerous user input errors. For example, sometimes I get weird effects because I left a skill toggled as an AoE by accident, causing some weird things to happen. Things like that will be a pain when it comes to quality checks, but overall I'm content with the system for now. So to wrap up, when you press a button in an RPG, or any game really, the skills each contain all the information embedded inside of them, and through a web of decision making, the game determines what to do with that data. You can sleep well knowing that there was a nerd who spent an unreasonable amount of time to make things run smoothly on your screen. With all that said, I hope you found today's information useful. I'm still in the experimental phase of the channel, trying to find what does and doesn't work for me, so feedback is truly appreciated. Consider liking and subscribing, and you can always wishlist Project Bloom on Steam. Link can be found in the description below. Thank you for watching, and I will see you next time.